you can probably predict by this point what we have to do to a function to make some kind of a change. You take a function and you replace something. You either replace x or y. And you're probably bright enough at this point to decide if we want to do some kind of expansion, or if we want to make a change horizontally, we replace x. If we want to make a change vertically, we replace y. If we want to expand or compress, we've done adding and subtracting a number to x, like we've replaced x with x plus something and replaced x with x minus something. We've done y with y plus something and y with y minus something. We haven't done multiplying or dividing. That's how you're going to get expansions and compressions. If you replace y with a number times y, when y is replaced with that number times y. Looks complicated, it'll make sense in a second. It'll make sense when you look at specific numbers. We just always have the problem that we want to isolate the y. And we are also going to go down here to where we're doing the x, which is right here. We are going to replace x with a number times x. We're going to do y replaced with a number times y, x replaced with a number times x. I want to show you what it looks like graphically. Must not push that again. This is a particular function. It doesn't matter what it is. It is something. It's actually the square root of 4 minus x squared. The reason it's like that is because I want something where it's pretty clear which way you're expanding and compressing. Grade 11, unfortunately, you work with one of the most difficult functions to see which way the expansion's happening. Because grade 11, you say, look, it's expanding or compressing vertically, and someone says, no, it's the opposite and it's horizontally. It looks like it's getting skinnier. No, it's really getting taller. And you might have had that argument with your grade 11 teacher. This one will be more obvious. If I replace, now I'm hoping I did the right thing here. This is, if I'm changing this number here, okay? When it's a 1, it's not there. There's a 1. It's not there. But if I change this, if I make this like this, so you look at what's happening if we make that into a 2. So we've changed y equals f of x to y equals f of 2x. If we replace x with 2x, the function gets narrower. It gets compressed horizontally. It works the opposite. If you multiply by a number bigger than 1, it makes the graph smaller. If you use a number smaller than 1, it makes the graph wider. It works the opposite. Just like when you replace x with x plus, if you replace x with x plus 6, it goes in the negative direction. It does the opposite. If you change x to 0.5x, it makes it wider. Okay? We'll go back to this where it hasn't been expanded or compressed, if possible. If we do this now, if I replace y with 2y, it's half as tall. How you would probably write that, though, is you wouldn't say 2y equals f of x. You'd write that as y equals a half f of x. So as you work through this tutorial, you're going to have to get used to the fact that if you say something as 2y equals f of x, it's the same as y is a half f of x. Or if you make this into a almost, come on, it's wonderful watching someone else. 0.5y is the same as y equals 2 f of x. It's taller. A number, if you have a number smaller than 1 over here, it makes it taller. Number bigger than 1 makes it shorter. That is your